Hello, my name is Juan Felipe Cañas, and today I am going to present the mechanical properties of material. Let's go with him. Introduction. Mechanical properties of material describe how material respond when a force or a load is applied to it. And these properties allow us to count whether a material deforms, breaks, recovery is original shape or with them large alone. That's very important in engineering, construction, and industry because they help in crossing the properties material for each application. Now, how are these properties determined? These properties are determined through laboratory tests carried out using a machine called a universal testing machine. In this test, for example, a sample of a steel bar is placed in the machine and axial force is applied to it in order to determine its mechanical properties. That's for example the universal testing machine. And for example in the magic we can see a bar that had cross-sectional arc and the initial length. And we are axial force is applied to bar along. Um, we must take into account that the force is directly proportional to elongate, according to how long. However, in the case and the spring displaced is replaced by the elongate for the bar. It is also important to consider that as the bar along its cross-sectional area the crest will it must remain constant. Now we going to talk about two fundamental concepts: U stress and strain. U stress. Um, what is stress is the material. Stress is the force applied to material divided by the area over which the force R is it is used to measure how intense the internal force is within the material when a load is applied. The stress force is um, sigma stress F applied force A you are over which the force act. Strain. What is strain? Strain is change in shape or size that a material experiences when a force or load is applied. When a force at a material is made stretch, compress, bend, or switch. That change that occurs in the material is what is called strain. Strain is represented by the grand letter epsilon. And epsilon, you stress, you Young model. Strain is the change in shape or size that a material experiences when a force or load is applied. When a force acts on a material, it might stretch, compress, bend, and the change that occurs in the material in what is called a strain. Strain is represented by the grand letter epsilon, called a change in length E L sub 0 initial length. This is relationship between stress and strain. Describe how the shape or shape of the material change when and force is applied. When and force is applied to material X production and internal stress that cause deformation is the material. The relationship is represented by the stress and strain and graph. In this graph, we can observe several aspects related to the mechanical properties of material. Point 1. There is proportional limit, which is the point where in the stiffness constant or joint module stone weight constant. That is when hook long is no longer variable. Point 2. The elastic limit. This limit is point at which the material can no longer return to its original shape. These 2 points are located in the elastic region. 3. Point 3. In the GL point, which is the point where the deformation of the material begins to become permanent. There are upper GL point and lower GL point. Now for point 4, the ultimate stress, which in the maximum stress value that the material can withstand, that is, whose before in the begin to fail or break. Finally, point 5, the fracture point, which where the material fail or break. Based on this, we must understand that there are several types of stress and several types of strain. Stress. Tensile stress. Tensile stress occurs when a material is subject to forces that pull in the opposition direction, causing the body to elongate. And when tension force is applied, the internal particles of the material move apart, producing an increase in the elongate. Example, the tension stress can be observed in the cable of the suspension bracket. This cable support in the weight of the breaker and the vehicle be resistant pulling force. Compression stress. Compression stress occurs when force toward the center of material, causing the object to shoulder or be compressed. In this case, the particles of the material move close together. Example, the compression stress occurring in column or building. The column support the weight of the structure over them. Shear stress occurs when force at parallel to a surface of material, causing one part the material to slide relate to another. This production the angular deformation rather than direct change in the length. Sample shear stress. Shear stress can be found on bolt and rivet that connect structural components. Dexed element resists force that strict to slate one part relevant to another. Torsional stress. Torsional stress occurs then rise in the subject to pair of force on torque that cause rotation. And this causes the selection of the material to rotate relevant to each other. Sample the torsional stress. Incommonly observed in shafts used in the machinal systems such as energy or turbines where rotation produces a stimulating force. The example shows how the firm tics of stress are present in mine engineering application. Tip on strain. Longitudinal strain. Longitudinal strain occurs when the length of the material change due to tension or compression. Example, steel cable in the suspension brick striction is leaking under the weight of vehicle and the brick structure. Shear strain. Shear strain occurs when a parallel force acts on a material, causing a layer of the material to slide relevant to each other, which change is cheap. Example, voltage connect to a stay plate. Expressions shear strain when the plate trip to move in the opposition direction. We can conclude that depending on the type of strain applied to a material, it will deform in the different ways. This behavior in the allows influenced by the stiffness of the material. Stiffness. Stiffness is in the ability of material to resist the force when and force is applied. Into the words, it indicates how difficult it is to shake the shape or size of the material when it is subject to a load. Um, in addition, each material has its own over stiffness. For example, in the image, we can observe that each material has different stiffness. Or Jones model which affect how much stress must be applied of the material to the form or file. Application of stiffness. Stiffness is directly related to Young models, which is a measure of how resistant a material is to elastic deform. Material which and Young model such style deform very light under load. On the other hand, a material which win a lower Young model such as rubber deform much more easily. This property is very important in structural engineering because excusable deformation can affect the stability and and steadfastness of the structures. Um, Now, let's talk Cold War hardening or war hardening. Cold War hardening is the phenomenon that occurred when a metal is plastically deformed and low temperature. During this process, the material increases its strength and hardness, but it ductility decreases, which is the ability of the material to deform without breaking. In the other words, the material becomes stronger but less flexion. Um, and the graph show the elastoplastic behavior of material. And initially, the material deformed elastic and recovered in its original shape when the load is recovered. However, the stress exceeded the elastic limit. Um, a permanent plastic deformation occurs when the material is underloaded. Only the elastic deformation is recovered, leaving a residual deformation. Now talk the energy in the elastic region. Resilience. Resilience is the ability of the material to absorb energy when it is deformed, elastical, and to realize the energy when the load is recovered. In other words, is the vectory how much energy the material can store without undergoing a permanent deformation. In the strain graph, resilience uh, corresponds to the R under the curve in the elastic region. That is up to the elastic limit or yield point. Um, Dourness. Dourness is the ability of the material to absorb energy before breaking. Unlike resilience, to Tourness consider the entire stress and strain curve, and for the being unloading unit the fracture of the material. In the strength strain graph, Downess corresponds to the total R under the curve. And in this image we can see the deformating resilient only accumulate energy in the area under the curve and the limited elastic. Without two turnex, accumulate energy and entire are the under the curve up to fracture. And ductility. Ductility is the mechanic properties that describe the ability of the material to undergo plastic deformation before breaking. A ductile material can elongate or significantly change its shape, inward fracture, and when enforced in uplift. And in simple them ductility indicate how much material can stretch before it breaks. And in the way we can determine which material is more brittle and which in the ductile. Generally, this can determine usually those methods. A percentage of elongate is the measure with the following formula. LF is final length, L sub 0 initial length por 100. If the percentage of elongate is less than 5%, the material is brittle, and if it is greater than 5%, is inductive. This bowl indicates how much the material elongate before breaking. The reduction in the squall to the percentage of elongate, the difference is that incident of the length, which in the initial R and final R. If the reduction of area is less than 5%, the material is bitter. And if it is greater than 5%, it is ductile. This makes for how much the material digs before breaking. And with this we conclude the presentation of the mechanical properties of material.